I do expect you did some of the odds last night. Okay. We had homework? Yeah, see, just like college, they don't require and look over your shoulder every 2 seconds to see whether you've done things. Right? And then they just give you a test, right?
I'm just used to that.
No, there's no required math Excel. All right? It's just bookwork problems. It's on the schedule, 1 through 45 odd. Yeah, it was changed, I believe. I had it updated in the module on the page, and then I had to go back and change it on the calendar. You're right. So I trust that you did a few of them. Obviously, we didn't get through tons of notes, so you couldn't do the whole thing, obviously. Okay? So we need to keep rolling with the notes so you can finish them up tonight. How many degrees are in pi over 3 radians? I would recommend, yeah, you can set up a proportion. If you like to set up the proportion, you can do that. But I am going to recommend that you get used to the idea of doing the factor label method. So what fraction am I going to put here? Your choices are pi over 180 or 180 over pi. It has everything to do with knowing which unit you want to get rid of. See, we have radians in the numerator here. So what do we want in the denominator in the fraction? Don't we want radians down here? I mean, the whole goal is to get rid of the radians and to change it to degrees. So, do we want, since we know that pi radians is the equivalent of 180 degrees, what would that fraction in the blue box look like? What? No, we want degrees. You are right. That's true. It would be 180 degrees in the top and pi radians in the bottom. If the goal is to get rid of radians and only be left with degrees, you've got to have the correct unit in the denominator, just like they did in the chemistry and physics classes. Anything else? Reduce or simplify? Oh, by the way, let me ask you this question. When you're multiplying fractions, just curious, when you're multiplying fractions, do you have to have common denominators? Yes. When you multiply, you need common denominators. No. Hang on to that, right? Be strong. Be strong. Do not need common denominators. Okay? What do we do when we're multiplying fractions? Just straight across the top, straight across the bottom, right? Now, occasionally I hear people say, cross multiply. Ouch.
That's division.
Does this look like a proportion? No, it's not. Now, I know what they're saying. In their minds, they're talking about the idea of reducing. Taking something from the numerator, something from the denominator, and canceling them out. I understand that's what they're doing. But they use the phrase, don't say it at a party. I'm telling you, man. It's a good way to get yourself kicked out. Anything cancel out. Anything from the numerator and denominator we can get rid of. How about them pies? We have 180 over 3, folks. What is that? That's 60 degrees. Now, we're not going to be converting those simple ones. After we get used to the unit circle and the nice things on the unit circle, the only time we're going to be converting if it's something unusual that's not a common value. I mean, once we get used to the unit circle, I'm going to expect that you know pi over 3 is 60 degrees. Okay, part C here. Find the length of an intercepted arc by a central angle of 1/2 radian. Now, please notice, folks, that is kind of unusual. That does not say half of a pi. It says 1/2 of a radian. So they're using the decimal equivalents of radians. They're not using the multiples of pi. So arc length. Now, isn't the arc length just a modified version of the circumference of a circle? You're talking about the distance on the outside edge of a circle. What's the formula for the outside edge of a circle? Yep. 2 pi r. Yes, I know that's the same thing as pi d. That would work too. It is not based on pi r squared. I've seen a few people doing that today. That's the area, right? And that would be true if we were dealing with an area of a sector. But we're dealing with arc length. Since you're not dealing with the entire circle, I'm going to write this fraction in front of it. The part of the circle that you're dealing with over the entire circle. Part over whole. Folks, it's just a fraction of the circumference. Don't sit there and say, it's a new formula, I got to memorize it. Okay, it's not, folks. It's just a fraction of the entire circle. Now, in this particular case, they said we're dealing with 1/2 of a radian. Now, you and I figured out yesterday that 1 radian was the equivalent of about 57.3 degrees. So we're talking half of that angle. Just to give you an idea. If this is in radians, what are you going to put in the denominator? Your choices are 2 pi or 360. Okay, you got about 20 seconds to talk to your neighbors and figure out whether you think we should put 2 pi in the bottom or 360 in the bottom. Yes, you need to talk to people. It's important. 2 pi or 360. What should go in the bottom of that fraction? 2 pi. So the top is radian. What do you think?
I come from pre-calculus.
That's right. Well, we have to stay with the same. If the top part of the circle, you're easy.
I don't
You're talking about 1/2. Okay, well, the whole circle, if you're talking about the fraction of a circle, then I need to know what would you call the whole circle if you're in radians, or what would you call the whole circle if you're in degree? Since this problem started out with 1/2 a radian and not a degree measure,
That's what I usually do.
they basically are choosing for me. They're telling me, you're sticking with radians. If they had chosen degrees, let's say they picked 15 degrees, then I would choose. So I have to look at the problem and pay attention to what they have chosen as what central angle measurement.
People do
It's
really
like
good at calculus.
inches or centimeters. If they decide to go this way, then I move this way. If they go this way, then I go that way. The denominator is, okay, you're looking, the denominator is an angle measurement. Next to it will be 2 pi r. I haven't written that yet. You're right about that. That part's still in the equation. So why should I choose 2 pi? Why should I choose 2 pi instead of 360? Because the original measurement they gave me was in radians. I have to stay with that. Of course, we have the circumference formula, but I think they gave me a radius, didn't they? What did they give me as the radius for part C? 5 inches. By the way, what's the denominator under 2 pi times 5? What is the denominator right there underneath the 2 pi times 5? It's a 1, thank you very much. Some people forget that. Yes, Miss Lee.
Okay, so I'm confused how you got the 2 pi for the denominator.
Okay. When you looked at the original problem, they made a choice for me right there. They told me that we were only dealing with radians for this particular problem. And since they picked radians, that forced me to choose a denominator of 2 pi. If they had said, let's let the arc be 15 degrees, then I would have chosen 360 in the denominator. It's based on the scale that they choose in the problem. I had to make a choice based upon what they gave me. I know where you're headed, and yes, you are correct. What? Anything cancel out?
No, I was gonna say you didn't.
How about the 2 pi? Yeah, that's great. Nice. Always, always, always reduce before you multiply. Make your life easy. What is half of 5? 2.5. Thank you very much. It's true.
Just keep in mind. I know. I'm doing this quickly. You're absolutely right. I gotta get everybody in the room to be able to do it.
Okay. Okay. Come on. All right, so the last one says find the radian measure of a central angle that intercepts an arc of length s in a circle of radius r. Yes, I know that's abstract, folks. They didn't give me a whole lot of numbers to work with. Okay, so when they say find the radian measure, are they looking for what, I guess, are they looking for? They're looking for this part right here. So I'm just going to use capital P for that. They told me that the radius was r. That's pretty generic. And they told me the arc length was called s. Also really generic. Since they told me this was in radians, what would you put in the denominator? 2 pi, right? Because that's the entire circle in the radian language. Anything cancel out? Oh, nice job. They are asking me to solve for P. How do you do that? Folks, you got S equals PR. Public relations nightmare. What's P? Divide by R. Thank you very much. Yeah, I know that was a little abstract. I understand that. But I just had to place the things in the formula the way they gave them to me, realize that we were dealing with radians, and look for what canceled out. I want to do this quickly so I can keep going to the end here, but let's say I start with 165 degrees, and I want to change that into radians. One of these fractions is going to be useful to me. Which fraction should I use? Second one? You are correct. I want pi radians on the top because I want the degree units to cancel. Now, before you start typing on that calculator, I want to let you know. You'll get an I-step calculator for this. You get one of those link, 5-function calculators. So right now, when you're using your current graphing calculator, just treat it like one of those. In other words, when you start looking for ways to reduce this, because no, folks, I am not going to accept a decimal. All right? So when I want the fraction for this, think about what goes into 165 and 180. Start thinking about ways to reduce it. You can use your calculator because I'll give you the 5-function I-stepper to use for this. But don't just start typing on the machine and give me some weird decimal. Start thinking about how to reduce. What goes into 165 and 180? Go. 5's a great choice. Go. Nice job. Yeah. So,
Yeah, I don't think there's a 100.
Actually, it does.
Oh.
Yeah.
well, second. I wish students would realize that I really wish students would have a
Yeah, that's the same thing as if I
understand it's a lot of work, but it should go a lot easier. So this, yes, you will. You're going to get an email from us. In fact, I emailed her today and asked me, right now, this wouldn't be allowed on a 5-function. So what? Yeah, think about 5. Yeah, that would be what I would divide by first. You know.
Were you on function calculator?
What do you mean?
Yeah, I was.
That's what I was asking earlier.
All right, I'm going to use now.
Nice. I like it. Okay. When I was in school, this is how they taught me to divide by a single-digit number without a calculator. So suppose I know that 5 goes into 165. I start with 5 goes into 16 how many times? How many times does 5 go? 3 times, right? With how much left over? 1. Now I focus right here on 15. 5 goes into 15 how many times? 3. 5 goes into 18 how many times? 3. With how much left over? 3. Now 5 goes into 30 how many times? So we just reduced 165 over 180 into 33 over 36. Is there anything that goes into 33 and 36? 3, and that's why you guys got 11 pi over 12. How did versus what? Okay, so they told me 3 goes into that. I was hoping that if I skip a step, please, feel free to say, what did you just do? Okay, so 3 goes into 33 11 times and 3 goes into 36 12 times. So do you see that, this is over 1, and we talked about how you go straight across the top and straight across the bottom?
What is rad?
Radians.
Yeah, but what is that? Just like a 1, or is it just nothing? Because you just got rid of it.
I got 11 here times pi radians, right? Because you go across the top.
Yeah.
Okay. Do I need to rewrite it?
Wait, why wouldn't you do
Like you'd have 11 over 1 times pi radians over 12?
Well, I don't understand what radians.
Okay,
anything
alright.
about radians.
It's a
I don't
unit,
know what
folks.
that is.
It's a unit, folks, just like inches or
It's like a variable.
it's not a variable, okay? It is a unit. It's like centimeters, inches.
What does it like measure?
It measures the interior angle.
Oh,
Now, this
right.
particular,
What's that little-
remember, just like degrees, you got 360 little tiny pieces inside of a circle. You guys are very used to that. Well, now instead of breaking it up into pieces called degrees, we're breaking it up into 2 pi radians. And I know that you're not used to that language yet. So it's a foreign concept, and you're getting used to it. I understand. And then so if you knew that 2 pi was 360, half of that would be 1 pi, which would be how many degrees? 180.
Or 1/2 is the height.
How close is 11 pi over 12 to 1 pi? Would you say it's close or far?
Far.
11 pi over 12, how close is it to 1 pi?
Far.
You're right, it is.
Wait.
Is 11 over 12? You typed it on your calculator, I saw you. 11 over 12. Did you get a number close to 1 or not? You got like 0.916 repeating, right? Those of you who typed that?
0.08.
That means it's close to pi. Is 165 degrees close to 180? That kind of makes sense in your mind? 11 pi over 12 is close to pi. 165 is close to 180. Yep, go.
Okay, so what kind of question, like, how is the question going to be worded? Like, when you ask.
Convert 165 degrees into radians.
That's it? Okay.
That's it. That's what we just did. Okay? All right, I'll give you another one. We'll go the opposite direction. Okay? 7 pi over 6 radians. Let's convert it back to degrees. What fraction are we going to use? 180 over pi. Now, why did we choose that? So that the radian units would cancel, right? Just like you did in all those chemistry and physics questions. Factor label. We want to get rid of that unit, so we have to make sure. Anything else cancel? The pi's. Before you start typing, do you see what I see? No, it's not about a child, folks. Yeah. Do the reducing first. If you do the reducing first, this becomes a lot easier. Don't multiply 7 times 180 and then try to divide that by 6 when you can think, okay, if I reduce, 6 goes into 180, how many times?
Oh, wait, no. Oh my gosh.
So this question was really about 7 times 30. What is it? 210 degrees. Yes? You're right. Okay, find the perimeter of a 60-degree slice of a large pizza. 7 inches? Man, is that really large? Seriously? Okay. So we've got this slice of pizza. It's got a 60-degree angle in here. We want to find the perimeter. Oh, perimeter. Is that a length or an area? Oh, that's a length, isn't it? That's an arc length.
We got a radius of 7. Okay. Isn't that whole part over whole thing coming up? All right. What fraction should we be using? 60 over what? What are you going to put in the bottom there? 360 degrees. That's right, because they chose degrees. Times 2 times pi times 7. Simplify it. Remember, I think you get a 5-function calculator for this too. So look for reducing as much as you can. That really significantly reduce things.
That's true. That's true. Well done.
Good. This is start. I want to make sure I get your questions answered. If I'm not answering the question now, keep asking so I get it right. Yeah, it is. It's a different unit of measurement. You just have to get used to it. Instead of being like Americans and fighting. When it comes to, switching over to the metric system. Okay, so what'd you do with this fraction in the front?
Reduced it.
Reduced it to what?
1/6.
1/6. Wow, that made life easier. Any more reducing?
Times. Oh wait, 2 and 6.
2 goes into 6 3 times. Hopefully you came up with 7 pi over 3. Now, my question to you, because I'm sure, does that make sense? My question to you is this 7 pi over 3, is that an angle or a length? It's a length, isn't it? Just because it has a pi doesn't mean it's an angle measurement. We get so used to this pi stuff and we think, oh, it's a radian. No, that's not what you have. You have an actual arc length. Could I type that in a calculator and figure out a decimal number of inches?
Yes.
Sure I could. I don't need you to do that. Yes, question.
Okay, so wait, so if it gives wait, no, okay, I'm gonna ask you anyway. So if it
Go ahead.
gives you like the 60 degrees,
Yep.
you do that to the perimeter and the length, it's gonna be a length, but if it gives you a radius, it's gonna be a degrees in the end.
If it gave me a radian measure, okay, now there aren't a whole lot of pizza joints out there that would probably measure their pizza in radian measures, although we could do that, which would be pretty cool. Suppose they said we have pi over 3 radians of pizza. That would be the same exact question, except I would be dealing with radians instead of degrees. So it is based on what the problem chooses from the beginning. And I'm not quite sure I've answered your question completely, but we will continue on and hopefully.
That's good.
Yes.
I kind of have a similar question there.
Yep.
So on the other arcane column, on both of them, you use the 2 pi.
Okay.
And then the first one was 2 pi 5, and then this one was 2 pi 7.
Okay.
Do you always use the 2 pi? Or
Yes.
was there something else?
Okay, because of that arc length formula.
Okay.
We're dealing with the circumference of a circle, so it has to be a fraction of an entire circle.
Okay. Cool.
Okay, so you use that equation on even if it's a radius or
Correct.
Okay.
Whether it's radians or degrees, it's the same exact. You just have to, the only decision you have to make is what you're going to put down here for the denominator. And that's based on what they chose to give you for the numerator. Okay. Normally, I actually take the pictures that are in the book and put them in the notes, and somehow I forgot this one. So I'm going to have to draw it for you anyway. So my apologies for my bad skills. All right. Yeah, these are really bad. Okay, so we've got this. We've got lane 1 and lane 2. Okay. Any track people here? No track people? Yes? Where do you run in the lane? In the middle, usually, right? Okay, but I think based on the way they've worded this question, we're going to have to run on the line of the inside of the lane. I don't think that's allowed, but I think that's what we're going to have to do for the way they have worded the question. Because what they said in this question was that the inside of radius of lane 1, so that would be from the center to here, is 33 meters. So it really seems like this person is running right on the line. And then the distance from here to the center of the next lane is 34 meters. How much longer? When they say how much longer, what mathematical operation are you going to be performing? Subtraction. Thank you very much. How much greater is one than another? Yeah, you're going to subtract. So we need to find the area, or I'm sorry, we should find the arc length of both of these and subtract them. Let's start with the bigger one. How do I find the arc length of this? So I guess that would be this edge right here. And yeah, I did a horrible job because it doesn't even look like a circle. My apologies to all the circles of the world. True. How do you find that? Do you know how many degrees that is? Unless you want to use radians. But I have a feeling most of you in this room will use degrees. How many degrees are we talking about? Come on, folks, how many degrees? 180 degrees, that's true. Out of how many?
360.
Ah, the total is 360, that's true. Times 2 times pi times 34, right? You probably need to do the same exact thing to the other one and then subtract them and tell me what you get. Okay, see what you get. That is, so that's right for the first part, right? Now you need to do it for the second part, the inside of this one, right? And then of course we said we would subtract them. Yes, so that's good for the big one. I'll find the other one. And then subtract. Well, this one's the big one. Now you're getting a small one. And then we said we would subtract those. Greater is on the other one. Right, then you take it. Right, so one would say and then we would do the same thing for the other one. Yeah.
Because they're high ones, right?
You just get one, too.
Well, one is. Oh, I guess.
Because when you have pi for both of them.
You got it.
Well, yeah, that's fine.
See, a lot of good answers here. A lot of you got the larger, the inside of lane 2 to be 34 pi. You did the exact same thing with the smaller one, and you got 33 pi. And then you knew that you were supposed to subtract them, and so what did you end up with? 1 pi.
Wait, okay. So wouldn't it just be like
Yes.
1 though? Why would you have the pi? Because when the pi's cancel out.
Well, we're not dividing. Okay, the difference here is, folks, they didn't say something like this. What percentage is one greater than the other? They said how much longer is one than the other. So they're forcing you to subtract. Okay, now if they were making me divide because they were saying something like, you know, how much greater is one than the other in terms of like a percentage, then yeah, I would have to divide them. And then you're right, the pi's would cancel. And I would end up with 34 over 33, which is obviously larger than 1, but some weird number.
So in this case, the pi is kind of like.
It's like, yeah, it's like x. If I said 34x minus 33x, you would just say 1x. Okay, angular speed. I might run out of time here today for, not for this question, but for another question that I wanted to do after it. So when you walk out of the room, I'm going to continue doing the video and then post it. You guys all should have gotten an email from me today where you could go look at all the videos because I put them all there. So I'm going to add this to the end of the video. So if you want to, if it'll help you with question 45-ish, I think. So, okay, so we're trying to take angular speed from this truck tire and change it into linear speed. We want to know how fast the truck's moving in miles per hour. So if you've done this in a science class or thought about this in a previous math class, you take the circumference of a wheel or tire, and that circumference would be the same linear distance that the tire would travel if you took it and cut it open. So a lot of times they talk about, well, if you cut it open and lay it down, you would end up seeing the linear distance. That the wheel, when the wheel travels one time around, that's how far you would move forward. So we're starting with 630 revolutions per minute. And by the time we get done, we want miles per hour. Whoa, can't spell. And yes, we will be doing a lot of factor label. The first one I want you to do is based upon the revolutions. So the circumference, what is the circumference of this particular tire? 2 times pi times a radius of 18. Yes, I know that's the same thing as pi times the diameter, which is 36 pi. Every time the tire goes 1 revolution, you go that far. Whatever that is. And yes, it's in inches. So why in the world would I write 1 revolution on the bottom and 36 pi inches on the top? Why wouldn't I reverse it? What am I trying to get rid of? Revolutions, thank you very much. We're still trying to get inches into miles. Let's start out by changing inches, 12 inches in 1 foot.
Do not ask me why I was watching that part. Okay, my wife made it. Okay. And in this particular episode, it's a horrible way to date, by the way. And in this particular episode, the group date had to answer a bunch of questions about aviation, and one of them was, how many feet are in 1 mile? Only one of the ladies got it correct. How many feet are in 1 mile?
5,280.
And how do you know 5,280?
5 tomato.
I've watched The Bachelor. What they teach you in elementary school?
5,000.
5 tomatoes. If you don't know that fact, 5280. 5 tomatoes.
52.
That's what they told me. And it works.
That's
52 with the cannibal meat.
Okay, so I'm trying to get rid of feet. So 1 mile, 5,280 feet.
So who's your favorite girl on The Bachelor?
Oh my goodness. I try to ignore it as much as possible.
What do you think of Henry?
That's the most ridiculous thing ever. Why would they bring her back? Okay. Get rid of the inches. Now we have miles per minute. We still do not have miles per hour. One last thing to do. What do we need to multiply this by? We need to multiply by 60 minutes and 1 hour. And now the minute units are gone. And the only thing we have left is miles per hour. And what do you do to get this correct answer? Multiply across the top. Then what? Multiply across the bottom. Then what? Divide. And you know what? A lot of you do it incorrectly because you try to do everything at once in your calculator. You should get 67.5. But a lot of you, try typing it in just to make sure you get 67.5 right now before you leave my room. But 67.5 is the correct, and a lot of people don't type it correctly in their calculator because they don't want to put parentheses around those two things right there, so they end up with a different number. Yes. Okay, so hopefully you type that in your calculator and you can verify that you get 67.5 miles per hour. If you're not, make sure you check with me in class on what you're doing to type it in wrong. But you're really multiplying across the top and across the bottom and then dividing. Now, a lot of you don't do the division correctly. I'm not going to worry too much about this this particular example. The difference between a nautical mile and a statute mile. A statute mile means it's what you're familiar with. It's a land mile. The truth of the matter is, unless you're a flat Earth person, the planet we live on is circular or spherical, which means a nautical mile follows the arc of the Earth. So it's like like the example that we talked about with pizza, but we've got this section. And to go from here to there is really following an arc. We don't normally think of it like that because, you have to travel a decent distance to be following an arc. Well, where, excuse me, where it makes any kind of significant difference. We are going to skip this particular example. You do not need to memorize statute miles versus nautical miles and how they connect. But it is that's the difference between the two, is just one's based upon the arc length of a circle. Okay, what I really wanted to do is, and the last thing that I needed to go over with you, you need to actually not do that, is to look at the compass bearings, okay? Compass bearings on a circle involve, let's see here, let me do this, and do this. Compass bearings involve a different scale. This is not like the unit circle, which we'll see more. Compass bearings start with 0 degrees being at the top of the circle, due north. And it goes, the positive rotation is in a clockwise fashion. So east would be 90 degrees, south would be 180 degrees, west would be 270 degrees, and obviously 360 would be back to the north direction. Okay? continuing to look at this compass scale, so this right here, northeast, that's 45 degrees. It's halfway between 0 and 90. Well, what do you think ENE means? That stands for east of north. East of north. And what do you think NNE stands for? That's north, or I should say, east of northeast and north of northeast. So that helps me understand which direction they're moving from the 45-degree mark. So when you're looking at east and they say northeast, that's halfway between 0 and 90. If they're saying southeast, that's halfway between 90 and 180. But then they give you this other letter, which helps you understand even further where to go from that. And yes, the distance from here to here is 22.5 degrees, which is half of 45. So every little measurement around here, every little smaller increment, these are all 22.5 degrees. I mean, in terms of movements, not in terms of bearing. Bearing is completely different. Okay, so that's a description of how the bearing scale works. I want to look at, ooh, it's not 45, it's 43. Whoops. I think I said the wrong thing, 7th period. 0 degrees, once again, that's due north. 2 Coast Guard patrol boats leave Cape May at the same time. One travels with a bearing of 42 degrees, 30 minutes. That would be the first one. So they measured that arc, and that's where that boat headed out. The other one was 52 degrees, 12 minutes. So that would be the second arc. If they travel at the same speed, approximately how far apart will they be when they are 25 statute miles from Cape May? So, in other words, if you think about this like a right triangle, these would be the hypotenuses, or more technically correct, hypotenuae. You know from the song Hypotenuae Joe? Where did you come from? Where did you go? Where did you come from? Hypotenuae Joe. You know, that kind of thing. These are each 25. Now, I'm going to zoom in here a little bit, basically. So we've got 25 miles here and 25 miles here. I think I just incorrectly drew this shape, because at the end here it should be an arc, not, well, maybe it says approximately how far apart are they. Do they really want it to be an arc length question? Well, on the water it wouldn't be an arc length question. Relative to the center of the earth it would be. So, we're going to treat this like an arc length question, but I think technically it's probably not. It probably doesn't make a difference to really matter. So we do need to know this angle in between, okay? And the question is, how are we going to find that angle? It has everything to do with these bearings. We are going to subtract them, but we're going to have to change them. So 52 point something and 42 point something. And yes, we would take that 12 and divide by 60 like we did yesterday, and we would take that 30 and divide by 60 because those are both minutes. And to convert, so that would be 42.5. 12 over 60 is 0.2, so we have 52.2 minus 42.5, which is 9.7. Now, if we do part over whole, the part of the circle that we're dealing with is 9.7 degrees. The whole circle in degrees is 360 degrees times 2 times pi times 25, the radius. And if we use our handy dandy machine, which I need to use the right tool, let's clear that off, and we'll do 9.7 divided by 360 equals that times 2 pi times 25. That's not right. Let's try that again. 9.7. It'd be better if I had a nicer calculator than this. Times 2 times pi times 25. Oh, there we go. 4.23 miles. All right. I'm doing this quickly using a different formula. If I assumed this was a triangle, this would be a, let's see here, would this be a law of sines question? Because you have a known angle, but you don't have the known opposite, so it'll be a law of cosines question. So 25 squared plus 25 squared minus 2 times 25 times 25 cosine 9.7 square root of that. I got 4.227, so virtually no difference. Yeah, it would be an arc length question if it was based on the center of the earth, but if they're just trying to ask on, the surface of the water, kind of looking at an overhead view, how far are they apart? It really is not an arc length question. Anyway, thought I would show that to you for your homework. Have a great evening.